Hi, everyone. Good afternoon, and welcome to our presentation, Keeping Python Fun. First, a little bit about us. My name is Olivia, and I'm joined here today by Brianna, Archit, Ella, and Arav. We're all students at Issaquah High School and members of the Issaquah Robotics Society, also known as First Robotics Competition Team 1318. We're also known under the acronym IRS, which is why we have our formal uniforms and ties. They're a little joke on the tax agency. And we're also joined here today by one of our team's members, Stacy Irwin. Stacy is a data scientist with the Pacific Northwest National Laboratory and graciously volunteers copious amounts of his time to help us code and learn. We're really excited to get started with our presentation, but before we get started, we need to set one thing straight. We are not BattleBots. We don't shoot flames out of our robots. We don't have giant spinning saw blades, battering rams, or hydraulic crusher attachments. And we don't even try to flip our opponents over, because that would probably result in being disqualified. So, if we're not BattleBots, what's our version of robotics? We'll cover that during the rest of our presentation. So today we're here to talk about how we use robotics competitions to learn Python, data analysis, and application development. First, we'll go over some of the realities faced by today's high school students and the challenges that stem from teaching students Python as part of an elective extracurricular activity instead of inside of a classroom. And then we'll talk about some of the good practices that we've learned over the years facing those challenges and discuss some takeaways that are applicable to more than just high school students. Before we proceed, I should point out that our presentation doesn't contain anything that's actually new. There are many things that we figured out through years of trial and error, but it didn't take much research to realize that everything that we had learned had already been discovered by previous educators and researchers. Here are a few articles that we like on the topics. The authors listed here are affiliated with King's College London, University of Michigan, Plotly, and Georgia State. Okay, so we know that we aren't BattleBots, but what we are is a team under First Robotics. FIRST, or For Inspiration and Recognition of Science and Technology, is a global robotics program reaching almost 800,000 students each year. They have the mission to help students gain the skills needed to become future leaders in STEM, and we participate in the First Robotics Competition, FRC, which is their program aimed specifically for high schoolers. So let's discuss a little bit about what robotics is all about and what the purpose of robotics is. By the way, this is a photo from our robot from 2022 for the game Rapid React. We like our robot pictures, so that's what we're using for the transition slides. So, why robotics? We aim to widen STEM interest by providing the students at our high school with the access to learn STEM skills through robotics. We also aim to give them an avenue to use those skills in hands-on scenarios so that they can use what they've learned in real-life applications like a competition and building a real robot. On a higher level, though, our ultimate goal is to foster a mix of cooperation and competition so that students can grow throughout the program while also having a lot of fun and having a large community. Me personally, I joined this team with basically no technical experience, but over my time in robotics, I've had a lot of fun, and it's greatly influenced my future careers that I want to go into. Now I'll turn it over to Archit, who will talk a little bit more about analytics specifically and why we need that in a robotics program.
Hey everyone, my name's Archit, and I will be discussing how our group, the analytics group, helps our team's mission overall. The analytics group is one of the many sub-teams within our team, and ultimately we support the team's overall mission, which is to give students access to STEM skills and give them the confidence they need to pursue STEM careers in the future. We do that by collecting, analyzing, and interpreting data specifically to improve the team's overall decision-making processes. In a practical sense, though, we want to teach analytical skills that students can use later on in college, their workforce, or even in fun projects that they may wish to pursue in the future. We mostly use open source tools that can be used anywhere without worry of any infringement or licensing. Giving students opportunities to practice programming in a fun and safe environment, as well as one that encourages competition, is one that promotes confidence. And students with confidence are more likely to learn new skills and attempt challenging tasks, leading to further growth. However, at the end of the day, to be honest, we seem to spend most of our time trying to figure out how to use data to win our competitions. All of the other objectives are achieved via unfortunate side effects. And now I'll discuss how data analytics helps us be more competitive as a team. First, here's a little bit about how FIRST robotics competitions work. Each year, a completely new game is announced, and this new game has a new set of rules and new set of pieces that teams must learn to work with and design and build their robot to cater towards. We also have to build whatever other tools that we want for a competition during this time, and this includes our data analysis software. That brings up the question, with such limited time, why is it that data analytics deserves any resources? Well, it helps us win competitions. But how is this? Here's a little bit about how competitions work. First, they're divided into two parts, randomized qualification matches, and then an elimination bracket. In each of these matches, 6 robots compete at a time, separated into 2 alliances of 3 versus 3. Each alliance competes against each other to score points and complete objectives, acquiring ranking points. In qualification matches, each of these teams are randomized, and they are ranked individually based on their average performance in each of these matches, acquiring ranking points, as I mentioned previously, which determine their seeding before the elimination bracket. All of the 3 robots on the winning alliance receive the same amount of ranking points, however, and what happens because of this is it's harder to differentiate between the robots, and this is where data analysis comes in. Teams that are the highest ranked in qualification matches get to select which teams they would like to work with for the elimination round, or the playoffs. This process is known as alliance selection, and it's essentially the same thing as a draft. However, it occurs in the middle of our competitions. Alliance selection is a timed and high-pressure environment where the teams must select one team out of anywhere from 30 to 75 different teams in under a minute. At one of our regional competitions this year, rankings were changing in the last minutes, which made it so that we had to use our data analysis software to accurately determine which teams would be available to pick and which ones we would want to pick in response to the rapidly changing rankings. Having our visualizations made it a lot easier to make more objective decisions under this pressure. With data analytics, we can make decisions about individual teams and opponents on a per-match basis. Aggregated data that's open source may be useful at times, but doesn't have the exact emphases we need. There are certain aspects that we really wish to emphasize and which we place more importance on, and being able to collect and interpret our own data helps us make better decisions overall. An example of this is Team 2930, which ranked 20th in the official seed. However, on our charts, they showed up as the 5th highest scoring robot. Having this information is crucial in determining whether we want to pick this team or not, and this team's competitive viability overall, allowing us to make better informed decisions and perform better overall as a team. So here's essentially how our analytics applications work. We have 2 different applications that we build and use throughout the season. We have a local Python Flask app to collect data, and we have a Plotly Dash app that runs on a software called OnRender to visualize this data. And the photo in the upper right depicts how we have our scouters collect data on the tablets, and on the bottom right depicts our Plotly Dash app. Now I will be handing it over to Ella to tell us a little bit more about our robotics students.
Hi, I'm Ella. So now that you've learned about our program and our need for data analysis applications, let's learn about the students who will be training to build those applications. If we want to have an effective training program that helps our students to learn and thrive, we have to understand where our students are coming from. But first, let's go on a tangent and discuss computer science education in secondary schools in our state. In Washington, only half of high schools offer computer science courses, with our school included. However, in the past school year, only 5.1% of students took one of these courses, and of that small percentage, only 28% were girls. One of the benefits of our robotics program is that it gives students another opportunity to learn CS without ever having formal instruction. Now let's consider the students on our team, the IRS. We're a large suburban high school in an area where many families already work in the tech industry. We took an informal survey to learn more about our students' experience prior to joining robotics. We found that most of the people who join our team start out with very limited experience. Although many members feel comfortable using block coding, many feel less comfortable using more complicated languages like Java, Python, and JavaScript. Tools that often facilitate the use of these languages, like CLIs and IDEs, are also mostly unused or unheard of by our students. Despite this, almost all the students on our team intend to pursue a STEM-related career. We were curious about how our students' attitudes towards programming changed depending on their career. Attitudes varied within each career area, but we do have students who intend to pursue medical, engineering, or scientific careers who don't expect programming to play a significant role in their future. But now we'll review some of the advantages that come from teaching with robotics. People often think of time constraints and uncertainty as bad things that you'd want to avoid while teaching, but we consider them to be beneficial aspects of our program. One of the unique challenges of robotics competitions is the short time frame. There are only 8 weeks to design, create, and test our applications. New competitions each year means new code to write and new challenges to work through. But that also means we have to create an application to analyze a game that we've never played before. Students have to deal with that uncertainty by analyzing the game manual, making predictions, and choosing what data to track and how we want to display it. This fast-paced process forces us to learn how to prioritize features, get quick feedback on design decisions, and carefully manage time to get everything done before competitions start. Another advantage of robotics is that we get to build an application we're actually planning on using. Our data visualizations are used by all the students on our team and by many others on our alliance. This means applications need to be easy to understand by everyone and reliable to actually help meet our goal of winning competitions. Although this creates additional pressure, having a real purpose in mind throughout the learning process makes robotics so much more rewarding than classwork. The experience at competition is another unique feature of robotics. With so many outcomes depending on alliance selection, it's extremely important to the team that our applications work as intended. That's why often our time at competitions is spent debugging. This might be a sign that we should improve our testing process. But for now, Brianna's going to talk about some of the other challenges we face and how we address them.
Hi everyone, I'm Brianna. I'm going to cover some of the challenges that are related to teaching application development as a time-constrained extracurricular activity. As you can see, our team has some issues, but throughout the years, we have gone through these challenges and found ways to keep them as fun as possible. One of the challenges we face is getting students committed to learning through robotics. High schoolers have many other commitments that keep them busy, and over half of our team spends over 20 hours per week on homework, extracurriculars, or other commitments like jobs and families. This means we have students with a lot to learn, but not much time on their hands. So what gets them to stay with robotics? Our solution is to strive to make robotics fun. In order to keep students engaged and coming back, we need to get to the fun stuff fast and keep it fun. This means differentiating robotics from schoolwork by creating a fun and casual environment, using group activities so students can interact with their peers, and staying away from anything that resembles homework. Another challenge we have is a lack of knowledge using programming tools. For example, most of our students have never even heard of or used a CLI or IDE before joining robotics. This makes it hard to use many online training materials, as most of them assume that students have at least some proficiency with these tools. When teaching programming, it's hard not to overload students too early with all the tools needed to edit code and share version history as a team. This means you'll have to put a lot of thought into how you manage your first few training sessions. Whatever you do, don't spend the first few hours of instruction installing Git, cloning repos, or creating virtual environments. We call this tool trauma. And we're talking from experience here. We used to spend the first couple of meetings in the fall setting up new computers, so students wouldn't even write a single line of code until a few weeks after they joined our team, if they even stayed for that long. But there are several ways to avoid tool trauma. By putting students into small groups to work and learn together, we limit the total amount of technology needed, and we promote peer-to-peer feedback. With this, we don't bore new students with how to use all of our tools from the start. One way we do this is by starting with online notebook environments, as they eliminate the need for complicated outside tools like CLIs and IDEs. Also, students with many years of experience using these tools can help guide new students whenever they need help. And finally, having fun and easily accessible guides online with how to use these tools allows students to work independently and learn on their own time. And for our next challenge, I know we all love Python, but when making web applications, there are many other languages and technologies needed for the front and back end, which students can't learn and master all within one competition season. When trying to learn several new applications, giving high schoolers who are already burdened by classwork more assignments and lectures makes robotics unenjoyable and no different from actual schoolwork. By allowing our students to choose the technologies they want to master, we have many people that are able to come together and build a full system. Our analytics team is divided into the people who focus on making the data collection application with tools like HTML and JavaScript in Flask, and those who make the visualization with our collected data on Plotly. Next, our mentor Stacy is going to discuss a few more challenges.
Okay, so hello everyone. I chose to present the slide on this challenge because I think I am the one who has struggled the most with this challenge. And actually, I need to put my reading glasses on so I can see my slide. So I think most of us would agree that when we receive constructive feedback from other programmers who are more experienced with us, that helps us develop our skills much faster, helps us avoid some common pitfalls. And I have some good news. If you look, there's a lot of scientific research that backs up that intuition. That is actually true. So why then would this be so difficult? Well, we're a extracurricular activity, so I do not have the ability to enforce homework assignments. We don't give any grades, and we also have a large number of students. And if it's not build season, when we're working for a competition, I'm only going to see them like once a week, right? And so like at the beginning of last year, I'd have like 25 new students show up, all wanting to learn analytics and programming. That's a lot of students to be tracking their individual performance and be able to give them feedback. Very challenging. All right, so anything resembling grades and more homework is not going to work. All right, you're all nodding your head. You're all like, yeah, why do you have a slide on that? That's obvious, Stacy. I'm a little bit embarrassed to admit, for many years it was not obvious to me. I was trying to do something that I didn't recognize was a lot like homework. So, we were doing a lot of stuff in like Google Colab notebooks. I'm like, hey, just share it on Google Drive, and you can share it with me, and I'll send you a nice email, I'll send you some tips, and I promise, not to flame on your code. And, like I said, 25 students would show up. In a good year, I would get like maybe 2 notebooks shared with me over like the entire year, right? So as much as I was trying to provide people individualized feedback, it wasn't working. It wasn't working. It's not something the students wanted to do. And thinking back to the kind of stuff I liked in high school a long time ago, it's like, yeah, I wouldn't have wanted to do that either. So the solution I finally realized was don't worry about it. Okay, that seems kind of counterintuitive, but because we are doing real world projects with software that we're going to use, we have 2 kinds of feedback that occur just naturally, the way we do things, and they work pretty well. So the first one I'm going to talk about is peer feedback. So we're putting students in small groups. We're often putting students in groups with maybe a few more experienced students, with a few less experienced students. And as they're working together and working through problems, feedback just naturally occurs during that process. It's great. The other thing about that kind of peer feedback is it occurs in real time. So think back to my earlier process of like, hey, share a notebook with me, I'll review it, I'll send you an email back. Okay, it's going to take them 3 days to get around to sharing the notebook with me. It's going to take me a day to review it if I don't have a bunch of stuff going on my day job. Day to get it back, 2 days for them to get around to reading it, right? I mean, even if they read it, it's like a week later after they wrote the code. So real-time feedback, I think, makes a huge difference. The other type of feedback is what I call reality-based feedback, right? We're building an application that we're actually going to use. So every bug that people have to troubleshoot and fix, and maybe have the thought that, gee, I don't want to have to do that again, the experience of using an application that you actually built yourself, all of the feedback you get from the users of your application on what they like, what they don't like, that is fantastic feedback, probably a hell of a lot better than anything that I could type out at them in an email. So I got to admit, I think one of the reasons it took me so long to come to this realization, why this was so hard for me, a little bit about me. I spent 20 years in the Navy, nuclear submarine force, you know, hanging back and just sort of monitoring the situation and kind of being hands off and just making sure people don't get into danger, just like, let's see what happens. That is just not something we did, right? That is, no, I was not trained to do that. So what's the point? The point is that sometimes to be successful later on in life, you have to unlearn things that you did earlier. Even though earlier in life, they worked really well, you still have to unlearn them because they're not right for the current time. All right, so next item, challenge, different skill levels. So, you know, most high school freshmen, right, they've never used a command line interface before, but occasionally we'll have students show up who are already fairly advanced in programming, and in one case, they already had an app on the Android App Store, right? So how do you help both groups of students advance? Well, you know, there's two things that are the absolute worst thing you could do, right? The first one is focus on just the advanced students, because then all the newer students are going to be completely lost. If you focus just on the newer students, the advanced students are going to get bored, they're going to wander off, and you're probably never going to see them again. And that's kind of a bummer, because they're good to have around too. So, what do? We just have a range of training activities. In fact, at any one meeting, we'll have several small groups, several different training activities going on, different difficulty levels, and then we'll kind of mix up the groups. So some training activities, you know, we'll have like some notebook, some data set that people have to work through, kind of figure some stuff out. We'll have junior students with, you know, more experienced students, and that works out well, and the less experienced students can learn from the more proficient ones. Or sometimes we just group them by skill level, and that works. It just depends on the situation. We like to mix it up. Okay, so we're almost there. We're at the final takeaways. I'm going to turn over to Arav, who's going to start talking about final takeaways. Thank you.
All right, hey guys, I'm Arav. And our first takeaway is that so far we've been talking about teaching Python to high school students. However, the training techniques that we use don't just stop working when they graduate and become adults. The techniques we use, such as hands-on and partner learning, real-world applications, and breaking down complex concepts, aren't just helpful for teens. They're effective and useful for adults too. Another key point we want to leave you with is this. You don't need a robotics team to teach Python effectively. Everything we talked about can be considered project-based learning, which has been around for a long time. One of the earliest and well-known advocates for project-based learning was John Dewey, a philosopher and psychologist whose career spanned the 19th and 20th centuries. Also, it's not an accident that one section of our presentation was called Understanding Our Students. Effective training programs reflect their students' knowledge, experience, and goals. Some good questions to ask when designing a Python program could be, what does your students want to do with Python? Or how much time do they have to learn? Or do they have prior experience with programming tools? Will they be working mostly on their own or with a team? Our next takeaway might not be that obvious, which is that real-world projects, time constraints, and unpredictability all sound like things you want to avoid while trying to learn a concept, except that they end up teaching you even more. Time constraints and unpredictability mean that you have to learn faster and prioritize, which are good life skills for more than just learning Python. Real-world projects sound tough for a learner, but they provide a more engaging way to learn than rote memorization. And you actually get to practice Python in ways that you get to use in the future. Now Brianna will introduce the next couple takeaways.
By getting to the fun part fast, we keep robotics engaging, which makes students return to robotics. Avoid anything along the lines of homework and allow students to focus on their individual strengths so they can come together as a team. Tool trauma can scare away a learner from Python or any other subject. To avoid this, early training shouldn't require extensive knowledge of tools. Instead, they should be carefully incorporated over time and incorporated into training activities to not overwhelm new students. This way, students are more likely to understand and remember how and why these tools are used. And now, Archit.
All right, so far our takeaways have been primarily discussing the emphasis on project-based learning as well as keeping things fun. And we also found that students are still able to learn effectively without grades or formal feedback. We found that informal peer feedback and intrinsic feedback works great, and every failure and success within a project implementation provides its own intrinsic feedback for people to learn from. And now Stacy will cover our final takeaway.
Okay, so the final takeaway is to embrace all skill levels. We want to make sure that everyone feels welcome at our activities, regardless of their prior experience. So I will tell you a little story. So back when our group was getting started, I would do a lot of pair programming because I didn't have students who had been in the program for several years who had the expertise. And I had a student that, man, I was trying to get him to understand just the concept of a function return value and what you would do with that. I got nowhere. I eventually just ended up giving code dictation. I'm a little embarrassed to admit I was thinking, is this guy going to make it as a software developer? Well, okay, you know how this is going to turn out. Now he's got his computer science degree and he's working in tech. So, and I got many stories like that. You cannot tell where somebody is going to be, how they're going to advance from day one when they're first learning Python. Especially when they're a high school freshman, but I think it's also true for adults too. You have to give people room to grow, give people room to catch up. Now, that takes us to the end. So thank you for attending our presentation.
Awesome. So I'll field some questions, and let's pop up the first one. So first one with thumbs up is like, what does that very first no tool trauma look like? Do you use something like an Adafruit circuit playground to get people coding with hardware feedback? So what is like the no trauma tool look like, I guess?
Well, we use Google Colab notebooks, and it's pretty much where like our mentor Stacy, he adds in instructions and pretty much like how these tools are used. And then there's like coding space, and we can run our code, see how it works pretty much in real time without having to use any command lines or IDEs and yeah.
And then, so there's kind of two-part question is, one, is anything that you do, like applications or software that you're building, available to other people? And then two, are there ways to help out, like from community here? That came from Matt.
Yeah, so our main visualization software is hosted online. You can find it at viz25.onrender.com, and viz is V-I-Z. So you can look through that. And then as for how to support our team, you can see 2 QR codes on the screen right now. The first one is more information about FIRST Robotics, and the second one is the link to our team's website where you can see more information about us, contact, just all the things about our team can be found on the website.
If I could add something, if you are interested in this program, you're interested in supporting it, teams do not dissolve usually because of lack of money. They dissolve because of lack of volunteers. So if you think this is kind of interesting, find some events in your area. You can like volunteer as one time to help out at events. And then, if you're really willing to make it a lifestyle, teams are always looking for adult mentors. And even if you're not technical, you're just willing to help wrangle people and organize, they need you. So that's the best thing you can do.
And then Filippo, I think we got time. Filippo asks, what was the funniest game you participated in? How was the overall experience? I think like funniest robotics game. Is that right, Filippo? Yeah.
Anybody got anything coming to mind?
I mean, we have funny stories.
I do have one, actually.
Yeah, go for it.
So this year's game was inspired by a submission we made in the COVID years, because at that time, of course, we couldn't play on a live field. And it was not necessarily funny in the traditional sense of being like, ha-ha funny, but like sort of seeing our idea be on the field and see other teams just like rush. Okay, so for context, there's these things called pits, right? Where you have robots stay for maintenance in between matches. It's just a designated area for teams to set up their maintenance fields. And so teams at the world stage would rush to our pits to grab our pins because we had pins from that original submission. And so seeing other teams be so enthusiastic and just like visibly run towards our stuff and try and get it, within minutes our pins would just be out and we would have to like restock on the hour at most. And so seeing that was just something I found kind of funny and interesting.
For context, First Robotics has a big pin collecting culture. So all the teams will produce their own pins, and it's usually a competition to see who can collect pins from the popular teams. So this year, since we had like a limited edition pin, it was very popular and fun to watch.
And then, so Paul asks about asking about robotics code. So I think it's two parts. Like, was Python used, and then Java Python? So how are you dealing with like all these different codes? And it sounded like you had multiple people being assigned, but how do you deal with like managing all of that?
Yeah, so in terms of analytics, we have two separate sections because we're building two different applications. So the visualization application that I talked about the link to, that's the one that we use basically only Python for. And then we have a second application that we build to have people collect data on. So if you saw in one of the photos, the way that we actually collect this data is we have people sitting in the stands during these competitions, like manually entering data. And that application uses a lot of JavaScript in order for it to work. And then as for Java, that's like a whole other code for actually programming the robot, but for just data analytics, those are the two main things that we're using. And then, do you want to add on?
If you're asking about how our languages interact, I think we mostly use like WebSockets. It was kind of like really a pain to get to learn at first, but that's how we have sockets in JavaScript and our Python server, I believe. Yeah.
And then, we're out of time. Sorry, we're out of time. But I did want to say, yes, awesome John Dewey reference. I'm a huge John Dewey fan. I get to say that because I'm moderating. So that's the end. Let's give our speakers another round of applause. And thanks so much for an awesome talk on keeping Python fun. And Python's always fun, but this was especially fun.